All right, today we're gonna be learning 7.6, which is called natural logs. Natural logs is the last type of log that we're gonna learn about. It is a new type of log, but the good thing is that it follows all the rules of every other log. So we just have to learn what a natural log is, and then apply what we know and what we've learned about all the other logs to natural logs. Okay. So first of all, the symbol for natural log is ln. Okay, I don't know why it's not NL. That would make more sense, but it's ln. Okay, and that button is right off to the side of the number 4 here on your calculator. ln, the natural log. Okay, so what the natural log is, okay, is it is the same exact thing as log base e, and e is a symbol for an irrational number. It would be in the same category as pi, okay? Pi is a symbol that represents a number. Pi is not a variable. Pi is a number. E is the same way. E is a number, okay? If we want to figure out what number E is, we go second and the ln button. Notice how that's E to the x, okay? So if I go second ln, I get E. And if I put E to the first power, then I'll be able to see what the number E is. So E is really the number 2.718281828, and so on. It keeps going forever. It's irrational. Okay? So I could, again, write something like log base E of 5. I could type that into my calculator. I could go math and scroll up here to log base. Okay. And I could go here, log base E to the first, of course, log base E of 5, right? Enter. Okay, but what I'm telling you is that log base E is the same exact thing as ln. So if I would just type ln of 5, I would get the same exact thing. Okay? So let's start doing some work with ln. Let's see how I can relate everything I know to the natural log. So let's say I have something like ln of 6x plus ln of 4x. And let's say that it said to condense or write as a single log. Remember, when I do that, addition just turns into multiplication. So that's ln of 6x times 4x is 24x squared. If I had something like ln of 3x over 2 and I wanted to expand that means I want to write this as many logs. Every time I see multiplication, I'll turn it to addition. Every time I see division, I'll turn it to subtraction. So that is ln of 3. I see multiplication plus the ln or natural log of x. I see division minus ln or the natural log of 2. Okay. If I had something like 3 ln x plus 2 ln y, and I wanted to condense, okay, then first I would make my coefficients become exponents. So that would be the same as the ln or natural log of x to the third plus the ln or natural log of y squared. Now that addition would turn into multiplication. So that would be the ln of x to the third y squared. Okay. All right, now if I wanted to solve a natural log, okay, if I wanted to solve a natural log, let's say that I had something like the ln of x equals -2. Let's start really easy. We want to solve. Okay, well, remember that the ln is the same exact thing as log base e. Okay, so if I wanted, let's go back to this. If I had like log base 2 of x equals 5. Okay, to cancel out a log base 2, remember I do 2 to the power of. 2 to the power of. So 2 to the power of log base 2 cancels. I would just have that x equals 2 to the 5th. So remember that ln is log base e. So if I want to cancel out an ln, the opposite of ln r is e. So to cancel out an ln or log base e, I do e to the power of. So e to the power of ln is gone. So I have x equals e to the negative 2. I could type that in my calculator, second, and the ln button to get e to the negative 2 power. And I'd be done right there. So x would equal 0.135. Let's see, if I wanted to do one like, I'm trying to find another, maybe one that's a little better than that for you here. If I want to do something like 2 times the ln of x minus 4 equals 10. First, I would get the ln of x by itself, so I would plus 4. I get 2 ln x equals 14. Then I would divide by 2. The ln of x equals 7. Now, to cancel out ln, again, I do e to the power of. So x is e to the 7th, which is x equals 1096.63. Now, in the same fashion here, okay, let's try to solve an e problem. Let's say I had e to the x over 5 power plus 4 equals 7. Remember that e's and ln's are opposites of each other. So I want to get this e by itself. I want a minus 4. So I have e to the x over 5 power equals 3. Now to cancel out e, to cancel out a base of e, so let's transition this for 1 second. Let's act like we had this for a second. 2 to the x over 5 power equals 3. If I want to cancel out a base of 2, I would log base 2. Both sides. So if I want to cancel out an e, I need to log base e, which is the definition of ln. So I use an ln, my ln or natural log both sides to cancel out that e. And I have x over 5 equals the ln of 3. And now I just multiply that by 5. Now, it doesn't become the ln of 15. You don't multiply the 3 and the 5 together, okay? What you do is you find the ln of 3, and then you multiply that answer by 5. So I have x equals 5.49. Okay, maybe last problem here. If I had one like e to the 3x plus 5 equals 6, and I wanted to solve, I would just get that e by itself. So I had e to the 3x equals 1. To cancel out my e, I ln both sides. So I have that 3x equals the ln of 1, and then I would divide by 3. Again, I don't do the ln of 1/3. I get the ln of 1. And then I divide that by 3. And in this case, I still get 0. Okay? I hope that helps. We are getting ready to take our test here soon, so keep working hard. All right?